This is SpaceTime Series 27, Episode 69, for broadcast on the 7th of June 2024. Coming up on SpaceTime, the Webb Space Telescope discovers the most distant galaxy known, the unveiling of a massive new collection of exoplanet discoveries, and new X-ray observations highlight changes in two of our most famous supernova remnants. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected the earliest known galaxy so far discovered, located a record-breaking 290 million years after the Big Bang, some 13.8 billion years ago. Over the past 2 years, astronomers have been using NASA's Webb Space Telescope to explore what's often referred to as the cosmic dawn, that period in the first few 100 million years after the Big Bang when the very first stars and galaxies were born. These most ancient of all galaxies provide astronomers with vital insights into the ways in which the gas, stars and black holes were changing when the universe was still very young. Back in October last year and again in January this year, astronomers used Webb to observe galaxies as part of the James Webb Advanced Deep Extragalactic Survey, or JADES for short. Using Webb's near-infrared spectrograph, they obtained a spectrum of a galaxy at a redshift of 14. That's a measure of how much a galaxy's light's been stretched by the physical expansion of the universe over space-time. The authors had already found hundreds of candidate galaxies from the first 650 million years after the Big Bang. But in early 2023, they discovered a galaxy which showed strong evidence of being above a redshift of 14. Now, that's never happened before. There were some artifacts of this new source which made them wary. It was surprisingly bright, something astronomers wouldn't expect for such a distant galaxy. And it was also very close to another galaxy, such that the two appeared to be part of a single larger object. When observed again in October last year as part of the JADES origin field, new imaging data, this time obtained with Webb's narrow near-infrared camera filters, pointed even more towards the high redshift hypothesis. Now, by this time, the study's authors knew they needed a spectrum to confirm their observations. So, in January this year, Webb's near-infrared spectrograph observed this galaxy, which by now had been catalogued as JADES GSZ 14.0, for almost 10 hours. And when the spectrum was first processed, there was unambiguous evidence that the galaxy was indeed at a redshift of 14.32. Now, that blows apart the previous most distant galaxy record, which was at a redshift of 13.2. This discovery was not just a new distance record. The most important aspect of JADES GSZ 14.0 was that at this distance, astronomers now know that this galaxy must be intrinsically very luminous. Now, from the images, the source was found to be over 1,600 light-years across, proving that the light was coming mostly from young stars and not from emission near a growing supermassive black hole. This much starlight implies the galaxy is already several hundreds of millions of times the mass of our Sun. And of course, it raises an important question. How can nature make such a bright, massive and large galaxy in less than the 300 million years that the universe had at that stage been in existence? And the data has also revealed other important aspects of this astonishing galaxy. The colour of the galaxy is not as blue as it could be. That indicates that some of the light is being reddened by dust, even at these very early epochs. JADES researcher Jake Hilton from the Stuart Observatory at the University of Arizona also identified that JADES GSZ 14.0 was detected at longer wavelengths with Webb's mid-infrared instrument, which was a remarkable achievement considering the distance. The mid-infrared observations cover wavelengths of light that were actually emitted in the visible light range, which are redshifted out of reach of Webb's near-infrared instruments. Jake's analysis indicates that the brightness of the source implied that the mid-infrared observation is above what would be extrapolated from the measurements by other Webb instruments, indicating the presence of strong ionized gas emission in the galaxy in the form of bright emission lines for hydrogen and oxygen. And that's interesting in itself because the presence of oxygen so early in the life of this galaxy came as a real surprise, because it suggested there must have already been multiple generations of very massive stars that had lived out their lives and died before the galaxy was even observed by Webb. Now, all these observations together are telling us that Jade's GSE 14-0 isn't like the types of galaxies that had been predicted by theoretical models, or for that matter by computer simulations, to exist in this very early part of the universe. Given the observed brightness of the source, astronomers can now forecast just how it might grow over cosmic time. And so far, they've not found any suitable analogues from the hundreds of other galaxies they've observed at very high redshift. Of course, given the relatively small region of the sky searched to find Jade's GSE 14-0, its discovery has profound implications for the predicted number of bright galaxies that are likely to exist in the early universe. This is SpaceTime. Still to come, discovery of a massive new collection of exoplanets and new X-ray observations highlight the changes that have taken place in two of the most famous known supernova remnants. All that and more still to come on SpaceTime. Astronomers have announced the discovery of no less than 120 confirmed and 6 new candidate exoplanets, that is, planets orbiting stars other than our Sun. The findings, reported in the Astrophysical Journal, was made using NASA's Transiting Exoplanet Survey Satellite TESS as part of the TESS survey program. It brings to more than 6,000 the number of confirmed exoplanets now known to exist. The new catalogue provides astronomers with a new database to explore, paving the way to study their properties and environments in finer detail, especially those planets thought capable of harbouring life as we know it. This latest instalment of the survey provides thousands of radial velocity observations, that is, measurements of the reflex motion of a star due to an orbiting planet's gravity, what astronomers call the wobble method. The observations are revealing a fascinating mix of planet types beyond our solar system. They include rare worlds with extreme environments to ones that could possibly support life as we know it. The study's authors analysed 9,204 measurements, more than half of which were taken over the course of 301 observing nights using the Keck Observatory's planet hunting spectrometer instrument. The results represent the single largest contribution to the understanding of the physical nature and system architectures of new planets TESS has discovered. With all of the radial velocities combined, they were able to calculate the masses of 120 confirmed planets as well as 6 candidate planets. The survey has revealed a vast diversity of exotic worlds. This time, astronomers honed in on planets orbiting so-called subgiant stars. They're future versions of the Sun, undertaking the largest homogeneous study of such planets to date. You see, eventually, after it runs out of hydrogen in its core, our Sun will expand to become one of these giant stars. Now, astronomers already have some pretty good ideas about what might happen to the planets in our solar system when the Sun expands into a red giant. But by directly observing these more evolved systems, they can begin to put together the puzzle pieces and tie the observations to the theory. The results could help predict the future fate of the Earth when the Sun swirls up and most likely engulfs our planet. In particular, the study bridges the gap to other systems that have already shown to somehow survive this fate, or those that are currently in the process of being engulfed. In another example of extreme worlds, the authors discovered the largest rocky planet ever found, cataloguing it as TOI 1347b. Their work suggests that terrestrial planets, that is those with rocky surfaces like the Earth, likely cannot have masses much more than 10 times that of the Earth. See, a larger planet would almost certainly accrete a thick envelope of lighter gases, such as hydrogen and helium from its nascent gas disk. And therefore it would produce planets far more similar to the ice giants Uranus and Neptune or the gas giants Jupiter and Saturn. This is SpaceTime. Still to come, new X-ray observations highlighting changes to 2 famous supernova remnants, and later in the science report, a new study shows that changes in global ocean circulation caused by climate change are increasing the frequency and intensity of extreme cold events. All that and more still to come on SpaceTime. NASA's Chandra X-ray Telescope has released 2 new movies spanning 2 decades, which are showing astronomers the dramatic changes that have taken place in 2 of the most famous objects in the sky, the Crab Nebula and Cassiopeia A supernova remnants. The new observations showed that the Crab Nebula shows a stunning view of the activity in the inner region around the nebula's pulsar, a rapidly rotating neutron star. A wisp is moving outwards at half the speed of light from the inner ring around the pulsar. It then appears to merge with a larger outer ring, visible in both X-rays and optical images. The inner X-ray ring consists of about 24 knots that form, brighten and fade. The new movie also shows a high-speed wind of matter and antimatter particles from the pulsar, which are ploughing through the surrounding nebula, in the process creating a shock wave which forms the inner ring. Meanwhile, energetic shock particles are also seen moving outwards to brighten the outer ring and produce an extended X-ray glow. The observations are also showing enormous electrical voltages, which are being generated by the rotating, highly magnetized neutron star. The star is accelerating particles outwards along its equator in order to produce the pulsar wind. Now, these pulsar voltages are also producing polar jets, which are spewing X-ray emitting matter and antimatter particles perpendicular to the rings. Meanwhile, new observations of Cassiopeia A have revealed the distribution of elements essential for life as we know it being ejected by the supernova explosion. This report from NASA TV.
The Crab Nebula, the result of a bright supernova explosion seen by Chinese and other astronomers in the year 1054, is 6,500 light-years from Earth. At its center is a neutron star, a super-dense star produced by the supernova. As it rotates at about 30 times per second, its beam of radiation passes over the Earth every orbit, like a cosmic lighthouse. As the young pulsar slows down, large amounts of energy are injected into its surroundings. In particular, a high-speed wind of matter and antimatter particles plows into the surrounding nebula, creating a shockwave that forms the expanding rings. Jets from the poles of the pulsar spew X-ray emitting matter and antimatter particles in a direction perpendicular to the ring. Over 22 years, Chandra has taken many observations of the Crab Nebula. With this long runtime, astronomers see clear changes in both the ring and the jets. Previous Chandra movies showed images taken from much shorter time periods, a 5-month period between 2000 and 2001, and over 7 months between 2010 and 2011 for another. The longer time frame highlights mesmerizing fluctuations, including whip-like variations in the X-ray jet that are only seen in this much longer movie. A new set of Chandra observations will be conducted later this year to follow changes in the jet since the last Chandra data was obtained in early 2022. The second billing in this doubleheader is just as spectacular. Cassiopeia A, or Cass-A for short, is the remains of a supernova that is estimated to have exploded about 340 years ago in Earth's sky. While other Chandra movies of Cass-A have previously been released, including one with data extending from 2000 to 2013, this new movie is substantially longer, featuring data from 2000 through 2019. The outer region of Cass-A shows the expanding blast wave of the explosion. The blast wave is composed of shock waves, similar to the sonic booms generated by a supersonic aircraft. These expanding shock waves are sites where particles are being accelerated to energies that are higher than the most powerful accelerator on Earth, the Large Hadron Collider. As the blast wave travels outwards, it encounters surrounding material and slows down, generating a second shockwave that travels backwards relative to the blast wave, analogous to a traffic jam traveling backwards from the scene of an accident on a highway. These 2 movies show Chandra's capabilities of documenting changes in astronomical objects over human timeframes. Such movies would not be possible without Chandra's archives that serve as public repositories for the data collected over Chandra's nearly 25 years of operations.
This is Space Time. And time Time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that changes in global ocean circulation caused by climate change may be increasing the frequency and intensity of extreme cold events in our oceans. Scientists already know that climate change shifts ocean currents and pressure systems, and the researchers have now found that changes in the East Australian current and the Agulhas current of the coast of South America have led to an intensification of ocean upwelling, a process in which deep, cold water is pushed to the surface. A report in the journal Nature Climate Change found that these upwellings can create colder killer events, leading to mass deaths of animals living close to their temperature limits. The authors were in fact able to link mass animal deaths in 2021 to such an intense cold upwelling, and they've given the example of bull sharks as one of the species that may be vulnerable to these cold events. A bit of good news now, and a new study has shown that kids conceived by IVF have no overall increased risk of childhood cancers than the general population. The new findings, reported in the Journal of the American Medical Association, looked at a cohort of about 8.5 million children, 260,000 of whom had been born using medically assisted reproduction. However, while the researchers say there was no overall increase in childhood cancer rates in the assisted reproduction cohort, there was a slightly higher risk of leukemia among those born by fresh or frozen embryo transfer. However, it's important to note this increased risk is not certain, and it's likely to have a very marginal impact on overall leukemia cases at the population level. The use of recycled concrete and glass aggregates in concrete production has now emerged as a highly promising means of increasing the recycling rates of waste materials. However, durability issues have plagued some combinations of recycled ingredients. Now, a report in the journal Structural Concrete claims researchers from Flinders University have developed a high-performance and sustainable concrete formula which can resist alkali-silica reactions, which until now have had a negative impact on the mechanical properties and durability of concrete. That was due to the significant silica content of some recycled aggregates. We usually think of the idea of UFOs, flying saucers and alien life as a fairly recent invention of humankind, most likely sparked by the Cold War fears of the evils of communism, as well as secret military tests in the 1940s and 50s, which government officials didn't want to explain. But actually, when you think about it, there are references to alien life going back thousands of years, all the way back to the Old Testament. There are tales like those of Ezekiel speaking of an immense dust storm coming from the north with an immense cloud full of lightning flashes and a huge ball of fire glowing like bronze. The passage goes on to describe 4 human-like creatures within the fire, each with 4 faces, 4 wings, and legs like columns with hoofed feet that sparkled from the fire like burnished bronze. In front, each had a human face. On the right side, the face of a lion. On the left, the face of an ox. And in the back, the face of an eagle. Ezekiel then speaks of things that look like wheels within wheels on the ground beside each of the 4-faced creatures. And the wheels were sparkling like diamonds in the sun, and with rims circled with eyes. Tim Mendham from Australian Skeptics says the idea of alien life is a reoccurring theme throughout history.
It goes back a long way, and certainly before the UFO flap that, as you say, started in the 40s and continues to this day. Not so much UFOs and things as much as...
There's a new one on X right now, in fact. It's like a manta ray flying through the skies above Florida. That's a brand new one, yeah.
I'll have to look at that one. Okay. Beliefs before this, the UFO flap, were largely about life elsewhere. If you know your H.G. Wells and look at the first Men in the Moon, which came out, I think, before War of the Worlds, maybe it was after. Yeah, where people travelled to the moon and they met up with the Selenites, who were the moon people. There's a movie made of it in the 60s, and they looked a bit more antish than people, but never mind. So certainly there was this idea of life elsewhere, and people back in the several hundred years ago, philosophers like the Bible, as you say, have always spoken about life elsewhere. And the way they saw it then, in their day, you're looking at the sort of 1600s, and when you're looking at some specific philosophers, they called it divine plenitude. attributes, which was basically the idea that God, in all her wisdom, wouldn't have missed the opportunity of populating the whole universe with living beings. If God could create life, whether humans or animal or whatever, why stop at Earth, right? Why not put it everywhere?
That's pretty cool that people back then were thinking that there were places other than Earth.
Oh, they knew there were places other than Earth. They'd seen planets after all, right? They'd known about Saturn and Jupiter, who were sort of, they were well known to the ancients.
Yeah, and they didn't know what they were. They thought they were stars.
No, they thought they were hard rock planets.
Did they?
Yeah. That's why you could put an animal on it for a creature, an alien. They didn't know they were gassy things and they go straight through. This is actually seen as being something of the move towards Copernicus. This is often because of the change of the view about astronomy in this time, from a geocentric Ptolemaic view of the solar system that the Earth is in the middle and everything else revolves around the Earth, to the Copernican view, which he wasn't the first, etc., but others had suggested it, but he was perhaps the most famous, suggesting that, no, the Earth is not in the middle, the Sun is, and all the planets, all these bodies, planets meaning wanderers, because they go back and forth in the sky, the night sky, revolve around the Sun. And they obviously knew about, was it Mercury, Venus, Earth, Mars, Jupiter and Saturn. They were known from ancient times, and Uranus and Neptune were sort of added not long after, and then Pluto after that.
You know the Earth will fit 62 times in Uranus, 63 if you squeeze hard.
Right, okay. Yeah, because Earth was a planet and the other bodies that they knew about were also planets, therefore they had to see them as similar. And if ours was populated, why aren't they populated? Like you could set up a society which they thought would be like our society. People would have social lives, they'd live in houses, they'd make music, contemplate the works of God, etc. And they probably sort of, did their own everything else as well. So the God was the centre of their explanation of why these other planets, these other bodies would be populated. So given the imprimatur of Copernicus, you like to say that these are all planets, these are all bodies, these are things rotating in space, these are solid, and that therefore you use the God bit, so God could put life on all of them. So they were pretty convinced 400 years ago, 500 years ago, that there was life out there. Not that they were contacting us, but they were out there. The question then came to, what are these things on other planets? Are they men or are they different sort of works? Had they been redeemed by divine intervention by Jesus, etc., as the people on Earth had been? Did they look like us? Did they not look like us? It was because you're not quite sure that they had been redeemed through the death of Jesus, that therefore you say, have all of these been following? Therefore they say, well, they're not humans. They would say that it's easy to reject the alien as being humans because that made life easier about how Jesus died for us here on Earth, but did he do the same thing on every other planet? So this is basically where our belief that aliens are not humanoid, from this idea that it's from a religious idea. If there is life, why not? Because God would have done it, but they couldn't be like us because Jesus didn't die for them. It's an interesting situation. But yeah, there's been people talking about life elsewhere for ages and ages and ages. So, but these people in the 1600s were torn between their religious beliefs and their scientific beliefs, and they tried to accommodate both. And I think that's where it becomes quite interesting from a historical and sociological point of view, even if they're not very good on the scientific point of view.
That's Tim Mindham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel. And on Facebook, just go to facebook.com/spacetime with Stuart Gary.
You've been listening to Space Time with Stuart Gary. This has been another quality podcast production from Bytes.com.